Okay, let's look at some practice problems for doing some conversions. We're going to kind of bring together what we know about balancing chemical reactions and figuring out how much of something is in something, like converting between particles and moles and grams of stuff. So let's start with this. Okay, we use 17.01 grams of H2O2 in this reaction. So you have H2O2 breaking down into H2O and O2. And more specifically, it takes two H2O2s to break down into two H2Os and one O2. Okay. How many moles of H2O2 are used in the reaction? In other words, we're starting with 17.01 grams. We want to convert to moles. So let's do that conversion. Make my pen a little bigger. There we go. Okay, so I'm going to start with 17.01 grams of H2O2. Okay, now I don't want grams of H2O2 anymore. I want to convert that into moles of H2O2. So I'm going to make a fraction bar. The unit I have to get rid of on the bottom is grams of H2O2. All right, what I'm trying to get to is moles of H2O2. Widen that out a little bit. Okay, so we have this fraction bar, this conversion factor that I have to figure out what to do with. There we go. Okay, well, I want a relationship between moles and grams. I'm going to be 1 with moles, which means I'm going to just put a 1 up by the mole side of this. So then this conversion factor is asking me, how many grams of H2O2 are there in 1 mole of H2O2? So I go to the periodic table. I look up the molar mass of an H and an O, and I make sure I add up 2 H's and 2 O's to each other. Okay. H is 1.01. So since I have 2 of those, it's going to be 2 times 1.01. Oxygen has a molar mass of 16. I just have 2 of those also, so 2 times 16.00. Okay, so if I add all that up, let's see, this is 16 times 2 is 32, and then 1.01 times 2 is 2.02. So this should all come out to be about 34.02 grams per mole. That's the molar mass of this H2O2, hydrogen peroxide, more specifically. Okay, so in 1 mole of hydrogen peroxide, I have 34.02 grams of it. Okay, which means I am all ready to do my conversion. Okay, my grams of H2O2 are canceling out when I divide these on the bottom, and when I multiply on top, I'm picking up the moles unit. So if I take 17.01 times 1 divided by 34.02, I should get my answer. 17.01 divided by 34.02 gets me 0.5. 0.5 moles of H2O2. So this is half a mole of H2O2. Okay, let's look at the next one. How many moles of H2O can we produce? Well, is that a typo? Is that supposed to be? I mean, we already found moles of H2O2, so that wouldn't be making sense to just ask for it again. How many moles of H2O can we produce? Well, I don't have grams of H2O, so how am I supposed to figure out moles of H2O? I also don't have particles of H2O. So how do I figure this out? Well, I'm going to use this relationship in my balanced equation. Up in my chemical reaction equation, this is basically telling me that 2 molecules of H2O break down to make 2 molecules of H2O and 1 molecule of O2. Okay, they tell me the relationship between the particles in this reaction, the reactants on the left and the products on the right. So even though I don't have an exact measurement of how much H2O is there, I can figure out how much H2O I can make based on the amount of H2O2 I have here. Okay, so we're going to have a new kind of conversion added into this. Okay, using this relationship in the reaction equation. We call this stoichiometry. Okay, it's a big fancy word for unit conversion in a reaction. So unit conversion in a stoichiometry is unit conversion in a reaction. Okay, so we're going to have a new type of fraction bar here that helps us convert between one substance and another that are related in a chemical reaction equation. Okay, so what this equation is telling me is 2 molecules of H2O2 can be used to make 2 molecules of H2O and a molecule of O2. But for now, I'm just kind of looking at these two guys. Okay, now as long as I keep this ratio the same and balanced, it should still work. So I could also say like 4 H2O2s and should make 4 H2Os and 2 O2s. Or I could say 8 H2O2s make 8 H2Os and 4 O2s. Okay, I could do it for 200, 200, and 100. I could do 100. I could do it for 2 million H2O2s, make 2 million H2Os and 1 million O2s. Or I could scale it up to the size of a mole. I could say 2 moles of H2O2 can be used to produce 2 moles of H2O and 1 mole of O2. Okay, this is what we're going to use for this new fraction bar. Okay, and we call this relationship that we're going to build, specifically in this case between our H2O2 and our H2O, a mole to mole ratio. Sometimes just shortened to a mole ratio or a molar ratio. But I like to say mole to mole ratio because it's telling us we're starting with moles, we're ending with moles. Okay? But it's moles of something else. It's a different substance. Let's scroll down here. How many moles of H2O can we produce? So, using what we have in this balanced reaction equation, we're going to use a mole to mole ratio to convert from moles of H2O2 into moles of H2O. Okay, so I'm going from moles of H2O2 to moles of H2O. All right, so I'm going to scroll this down a little bit so I can have a little bit more space to write. How many moles of H2O can we produce? So we're going to start with moles of H2O2, okay? Since we can relate the moles of one chemical to the moles of another. Bring this down here. Okay, 0.5 moles of H2O2. So I'm starting with, I want to cancel out that moles of H2O2. So that's going to go on the bottom of my fraction bar. Moles of H2O2 is going down here. Okay, what I want is moles of H2O. Okay, so they both have the unit of moles, but I'm talking about moles of a different chemical. Okay, so they act like a different unit. So this conversion factor I have here, relating the moles of hydrogen peroxide to the moles of water in this reaction, is my mole to mole ratio. Okay, that's what we call this. And this is the only time you cannot be one with moles. Okay, I love to say one with moles. I bring it up just about every opportunity that I get. But the mole to mole ratio is the only time we cannot be one with moles. Why is that? Because we need to look specifically at our reaction equation. What is happening in this reaction equation? Specifically, we have 2 moles of H2O2 that are basically being converted into 2 moles of H2O and a mole of O2. But again, all we care about is these two guys right now. Okay, so my 2 moles of H2O2 are becoming 2 moles of H2O. If I had exactly 2 moles of H2O2, that would become exactly 2 moles of H2O. But I don't have that. I have a half a mole of H2O2. So this conversion factor is what we use to figure out exactly how many moles of a different chemical we have. So, oops. If I take 0.5 moles of H2O2 divided by 2 moles of H2O2 that I'm using up in my reaction, my moles units cancel, and multiply by moles of H2O, I should wind up with an answer in moles of H2O. Okay, 0.5 times 2 divided by 2. Well, it doesn't change anything, which doesn't always happen. So in this case, oops, 0.5 moles of H2O can be made here. So if I start with half a mole of hydrogen peroxide, I can make half a mole of water, which is basically what this is saying up here. Okay, if I had 2 moles, I could make 2 moles. If I had a half a mole, I should be able to make a half a mole. Okay, by this mole to mole ratio, this 2-to-2 ratio. Okay, so that's all that's new for the mole to mole ratio. Okay, and now we can bridge from one chemical to another. We go from moles of one thing to moles of another, and then from there, we're just back to doing grams and particles for whatever new chemical we figured out. So down in problem C, how many grams of H2O can we produce? Well, let's see. I can figure out grams of H2O from moles of H2O. And I do have moles of H2O. I just figured out moles of water I can make from this. So let's bring this down here. All right. So I'm going to take 0.5 moles of H2O. And I'm going to convert it to grams. And now we're back into familiar territory. Like grams, moles, we can do that all day. So I'm getting rid of moles of H2O on the bottom here, so it will cancel out. I'm trying to get to grams of H2O on top. Let's use blue for this one. Okay, I want to get to grams of H2O up here. All right, so I have a conversion factor. And this conversion factor is asking me how many grams of H2O are in how many moles. Okay, now this is not a mole to mole ratio, so I am free to be one with moles. Okay, because I'm asking how many grams of H2O are in 1 mole of H2O. So I'm one with moles, and I got to get the molar mass of H2O. Hydrogen is 1.01. There's 2 of them, so that's 2.02 plus my 16.00 from my oxygen. So my molar mass of my H2O, my water, should be 18.02 grams for every mole of H2O2. When I work this out, I cancel out my moles of H2O. So 0.5 times 18.02 divided by 1 should get me 9.01 grams of H2O. 9.01 grams of H2O. And that's my answer. Okay, now I want to emphasize how important this is and what this does for us. Okay, we did this as 3 separate problems, going from grams of H2O2 to moles of H2O2. And then we went from moles of H2O2 to moles of H2O. And then we went from moles of H2O to grams of H2O2. But if you look at this big picture, if you imagine like we just stuck these fraction bars all together, we went from this fraction bar straight to this fraction bar, straight to this fraction bar, we used some amount of grams of hydrogen peroxide to figure out how many grams of water we can make in this reaction. Okay, I said I start with 17.01 grams of hydrogen peroxide. I'm going to make 9.01 grams of water, which is nuts. I didn't even have to go into the lab and measure that. Okay, it's a totally different chemical, and we can still predict how much we can make. This is the importance and the beauty of stoichiometry, being able to relate different chemicals to each other based on how they are in a chemical reaction, how they react or how they form something else. Okay? And we can do this for any chemical reaction. As long as we have a balanced chemical reaction equation, we can do this with a mole-to-mole ratio. Okay? That takes us from moles of one chemical to moles of another. Oh, it's so exciting. Let's look at some more examples. Ooh, okay. If we use 496.85 grams of H2O2, how many grams of H2O can we produce? Okay, so I want to go from grams of H2O2 to grams of H2O. Okay, so it's very similar to what we did up here. Just rather than asking in these individual discrete steps, we're being asked for it all at once. I will have grams of hydrogen peroxide. I want grams of water. Let's do it. Let's just do it. So I'm going to start with 496.85 grams of H2O2, because, I mean, what else do I have to start with? 496.85 grams of H2O2. All right. Now, in order to get from grams of H2O2 to grams of H2O, well, I can go from grams to moles of H2O2 using the balanced chemical reaction equation. I can go from moles of H2O2 to moles of H2O. I can relate those just like I did before. Okay, and then finally I can go from moles of H2O to grams of H2O. Okay, so this is kind of charting my course. This is what I have to do with my conversion factors. So my first conversion factor, I am getting rid of grams of H2O2. All right, I should wind up with moles. Oops, let's do this in a different color. I should wind up with moles of H2O2. All right, well, look at my fraction bar. How do I figure out how many grams of H2O2 are in 1 mole of H2O2? Because I can be 1 with moles. This is not a mole-to-mole ratio, so I can be 1 with moles. How many grams of H2O2 are in a mole? That's the molar mass. I add up 2 H's and 2 O's, which we did up there. We already have it. It's 34.02. So there are 34.02 grams of H2O2 in every mole of H2O2. That should help me cancel my grams units of H2O2 out. And now I'm at moles of H2O2. But we're not done yet, okay? Because I don't want moles of H2O2. I want grams of H2O. We still have more to do. So we're on to another fraction bar, another conversion factor. All right. So let's see. Now I'm trying to get rid of moles of H2O2. Okay. Now, if I want to learn something about this other chemical, about water, I can go from moles of one chemical to moles of another as long as they are related in a reaction equation, which I have up here. 2 moles of H2O2 can make 2 moles of H2O. So I go down here. 2 moles of H2O2 can be used to make 2 moles of H2O. Okay, which is this mole-to-mole ratio right here. Okay, whenever you are in doubt, moles is your universal conversion unit between basically anything you need. Okay, and to go from one chemical to another, we use a mole-to-mole ratio like this guy. Mole to mole. And as a reminder, the mole-to-mole ratio is the only time we cannot just put ones in for the moles and say, be 1 with moles. This is the only time you can't do that. Okay, so this should get rid of our moles units for H2O2 and instead pick up moles for H2O. I've now converted to moles of H2O, but we are not done yet. Okay, one last thing. I want to convert to moles of H2O. Or sorry, grams to H2O. Ugh. I want to convert to grams of H2O. So I have to get rid of moles of H2O on the bottom. Ooh, moles H2O down here. I want to get grams of H2O on the top. Grams of H2O. So what's this conversion factor asking me? Well, it's not a mole to mole ratio, so I can be 1 with moles. 1 with moles. Okay, how many grams of H2O are in 1 mole of H2O? Well, that's the molar mass of H2O, which I added up here. 2 H's and 1 O should be a molar mass of 18 point, 18 point, there we go, 0.02 grams of H2O and 1 mole of H2O. That should cancel my moles of H2O units. It should be getting me to my answer. All right, so if I take 496.85 times 1 divided by 34.02 times 2 divided by 2 times 18.02 divided by 1, I should get my answer. Now, multiplying and dividing by 1 is not going to change your answer. So if you want to skip those, that's fine. But do not skip the important stuff like the 34.02 and the 18.02, okay? Do not miss those because you're trying to skip ones and make your life a little bit easier. So 496.85, I like to just put all of it in. Times 1 divided by 34.02 times 2 divided by 2 times 18.02 divided by 1 gets me, let's see, 263.18-ish, and that's grams of H2O. And that is my answer. Again, without stepping foot in the lab, I can say if I use 496.85 grams of hydrogen peroxide and get it to all break down, I should make 263.18 grams of water out of that, which is crazy. And it's exciting. And it's how we're going to be basically figuring out whether the experiments we do in lab are good, if they are on track, if we're doing kind of a good job of getting all of the product that we're aiming for. All right, let's do another example. How many molecules of O2 can we produce? Okay, still using this 496.85 grams of H2O2. Okay, well, similar kind of path, except now we're going to be going from grams of H2O2 to, I want to get particles of H2O2 at the end of this. Particles of H2O2. Oh, sorry, H2O. Blah. H2O, there we go. Okay. So, I didn't change either of these because moles are like my universal translator between all of this stuff. Okay. Oh, and I'm not getting H2O, I'm getting O2 this time. This is why we're walking through these, because there's a lot to keep track of, and even I make mistakes on these. So let's just rewrite this. It would be good practice anyway, and it'll help me make sure I stop making mistakes. Okay, if I'm trying to go from 496.85 grams of H2O2, and I want to find molecules of O2, how can I get there? Well, I can change out of grams of H2O2 into moles of H2O2. Okay. Actually, let's do. Sometimes I get a little obsessive over my color coding. Moles of H2O2. Ugh, like that. My O turned out a little bit better. All right, from moles of H2O2, I can figure out moles of something else. Like in this case, I want to know moles of oxygen, of O2. Because moles of O2 can get me to particles of O2. So this is kind of how I'm charting out my course. We're going to have to convert from grams of hydrogen peroxide to moles of hydrogen peroxide, then go from that to moles of oxygen, and finally from moles of oxygen to particles of oxygen. Okay, let's do it. Scroll this down a little bit. So 496 man, this keeps dragging. 496.85 grams of H2O2 times a fraction bar, where I'm trying to get rid of grams of H2O2 on the bottom. Trying to cancel out my old unit. Okay. I can go from grams to moles, so moles of H2O2 is on top. And hey, I mean, this is no different than what's up here. So I'm just going to copy down what I had. I mean, I already did it. It's not like I'm plagiarizing. In 1 mole of H2O2, I can make 34.02 grams of H2O2. This will help me cancel out my grams of H2O2 units, and I'll be left with moles of H2O2, which is good, but we're not there yet. My next step is to go from moles of H2O2 to moles of something else. In this case, O2, moles of oxygen. Oops, let's do purple. So I'm going to make another fraction bar. Okay, I'm going to get rid of moles of H2O2 now because I'm done with that unit. Moles H2O2. Let's move this over a little bit. Didn't get that far out. Okay. And I want to try and figure out how many moles of O2 I can make out of that using my balanced reaction equation. Moles of O2. Okay, so this is my mole to mole ratio. Okay, mole to mole. It's the only time I can't be one with moles. All right, so I go and look at our reaction equation. If I had 2 moles of H2O2, I could make 1 mole of O2. So that's my conversion factor. 2 moles of H2O2 can be used to make 1 mole of O2 in this reaction. Okay, so that's how I'm going to convert from moles of H2O2 to moles of O2. Okay, so another fraction bar down. Our last step is to get out of moles of O2 moles of O2 and to get grams, or sorry, particles of O2. Molecules is just another word for particles of O2. So let's put that up here. Oh, I'm going to need a bigger fraction bar. Particles of O2. Let's stretch this out a little bit. Okay. So this last fraction bar is asking me, well, if I'm going to be one with moles, how many particles of O2 are in 1 mole of O2? It's been a while since we've used this, but there are 6.02 times 10 to the 23rd things in 1 mole of anything. So there are 6.02 times 10 to the 23rd particles of O2 in 1 mole of O2. Okay, my moles of O2 units cancel out. What I'm left with is particles of O2. Okay, so all we have to do now is plug all this in. 496.85 times 1 divided by 34.02 times 1 divided by 2 times 6.02. And I got to turn my calculator so I can get to the times 10 to the times 10 to the 23rd. All right, when I get, let's see if I can squeeze this in here, is 4.40. Oh, this is not going to fit. I'm going to have to move this down. 4.40 times 10 to the 24th particles or molecules of O2. Particles of O2. Kind of sloppy, but that's what my answer should be. About 4.40 times 10 to the 24th particles of O2. Okay, and again, I got this from grams of a totally different chemical. But the only new step here, the only new conversion factor is this mole to mole thing. Okay, we've done grams to moles before. We've done moles to particles before. The only difference is this mole to mole here thing in the middle. That kind of helps us bridge the gap between these two chemicals. Okay, so the math is really not all that different. Okay, it's just a matter of it's a lot to put all together at once. And I mean, you could tell by the fact that I messed some stuff up along the way too. I'd start bumbling through some of these, calling grams instead of moles, or getting the wrong chemical and things like that. So it can be tough. But I have something that will help you keep track of things, especially because as you start out, it's going to be a lot harder to do stuff like this, where you're charting out your path. So before I end this video, I'm going to show you kind of how you can start to train yourself to figure out your kind of path through these problems. Okay, so on Schoology, I have this stoichiometry island diagram that you'll see in the assignment, as well as a periodic table. But if you want a bigger version of this, you can download it yourself. We're going to go back to the Unit 6 folder. I'm going to scroll on down here. Okay, where it says Unit 6, Reference Sheets, Island Diagram, and Periodic Tables. I'm going to open this up. Okay, this stoichiometry island diagram, now a little bit bigger, is going to be a lifesaver in doing problems with stoichiometry, that relationship between moles of one chemical to moles of another. Okay? All we have to do is kind of follow a path to get from point A to point B to figure out our kind of answer and stuff. So let me see if I can, I guess I got rid of my little thing that allows me to write on stuff. But we can just kind of talk through it. So in that last problem, I started with grams of hydrogen peroxide right here. I wanted to get to particles of water, or sorry, particles of oxygen, O2. Man, you can really tell it. So this is why we need this chart, right? I'm starting from grams of one thing and trying to get to particles of something totally different. How do I get from here to here? Well, I can't just, sail around here. I have to hop from island to island, okay, following these paths. I have to go from grams of my first chemical, in this case, hydrogen peroxide, to moles of hydrogen peroxide, from moles of hydrogen peroxide to moles of my new chemical, my substance B, my oxygen, and then from moles of my new thing to particles of my new thing. So moles of O2 to particles of O2. Okay, so I have to take that path. Okay, along the way, to hop from island to island, it'll give you little hints like, hey, 1 mole is equal to the molar mass of our stuff in grams. Okay, or 1 mole of stuff is the same as 6.02 times 10 to the 23rd particles of something like atoms or molecules or formula units. And finally, to get from moles to moles, we got to use the coefficients from the balanced chemical equation to go from substance A to substance B. In this case, it was hydrogen peroxide to oxygen, O2. Okay, so Keep this handy. Keep it around. Use it to check your work. Use it to chart out your course from island to island, okay? From unit to unit, okay? And we can use this to get from anything to anything. We can go from particles of one chemical to particles of another, or particles of one chemical to grams of another. We can use it to get from grams of one thing to grams of another. We can do just about anything with this, okay? I can change from one chemical to another as long as I'm careful of my conversions and my mole to mole ratio. This volume part here and here we'll get to in a later unit. So for now, you can ignore this part. So really the only parts you need are this guy here and this guy here and the relationship between those two. Okay, and you'll notice the bulk of this diagram is just stuff we've already done between grams and moles and grams and moles and moles and particles. The only new thing here is this part right here. It's just going to seem a lot harder because we're putting together a lot of fraction bars at once. And there's a lot to keep track of from one chemical to another. But I have faith in you guys. I know you can figure it out. Good luck and practice. I promise it gets easier the more you do it.